to finish the 113 notes together, and you're going to do a little bit of practice for 113. Does everybody have it? Anybody need it? 3, 2, 1, I'm going. So remember we were talking about spending money at the Freiburg Fair, $5 for a ride, $8 for food. And then we wrote these inequalities about how we could spend our $50. And today we're going to graph it and see what the graphs actually mean. So I could just graph X. I could just graph Y, but I'm going to graph the equation that's going to do it all. It's going to take into account food and rides. But this is a tricky one. You don't want to put this into slope-intercept form. This is an example that it's easier to graph in standard form from the beginning of the year. So the strategy for standard form is to plug in 0 for one of your two variables. If I plug in 0 for Y, what does X have to be? 10. Remember we set up at the top that I could ride a maximum of 10 rides? I would like you to put a dot at 10, 0 on your axis. That means that I could actually take 10 rides if I wanted to, because X is our rides. Y is our food. If I plug in 0 for X, what did we say that Y could be? How would I solve this for Y? What's 50 divided by 8? Let's do it. 50 divided by 8 is 6.25. Could I buy 6.25 food items at the Freiburg Fair? No. Could I buy 7 food items? No. What's the most food I could buy? 6 food items. You're going to go and graph 0, 6 on the y-axis. Then you're going to use your ruler to connect your two dots, and this is going to be the graph of your line, and we're going to shade where our inequality would be. First of all, can I buy a negative amount of food? Can I buy a negative amount of rides? No. So my solution region is in the first quadrant, and it's this triangle bounded by that inequality. Quadrant, first, second, third, fourth quadrant. You don't know what that is? 1, 2, 3, 4. So this is the first quadrant. A quad means 4, quadrant. Oh, okay. So what does that shaded region represent? That represents all the possible combinations I could make. So, for example, could I take 2 rides and eat 8 food items? No, because I would overspend, right? 2 rides plus 8 food items would cost me too much money outside of my region. So give me an example of something I could do. I could just eat 4, I could do 4 rides. I could do 4 rides and 2 food. So if you wanted to use like your maximum amount of money, the further you go towards your line is you're using the maximum amount, right? If I use 6 food for 10 rides, I'm using the maximum amount of money. So I like this because it kind of is illustrating that an inequality is a feasible region of points, all of which are solutions. So there's no wrong answer. Any of those is okay for me to spend. This would be a wrong answer. If I try to do 2, 8, I spend too much money, right? So I shouldn't have done that on there. All right, so that's the idea of an inequality. So then yesterday, we talked about the algebra when we solve an inequality. So do you remember the one rule for solving an inequality? When you divide by what? Remember the rule I told you? When you divide by a negative, what happens? The sign has to change. So how can I get y by itself on that first example? Divide just by 2, right? Divide by 2, y is less than 3. I didn't have to flip the sign because I didn't divide by a negative number. What would you do on the next example? How do I get y by itself? Minus x. Did you say that I have to do any kind of division? No, so I would just subtract x, the sign stays the same, and now I have negative x plus 10. Okay, so the third one here has a little bit more going on with it. What should I do first on this next example to get y by itself? Minus 6x. So negative 3y is less than or equal to negative 6x plus 12. Those are not like terms, so I'm just going to leave them apart. So what's my next step to get y by itself? All right, and you said the magic words, divide by negative 3. So I need to make sure I flip that inequality symbol. The reason for that, there's a proof, or I could show you the graph of it, but when you make something negative, the bigger the negative number gets, the smaller the value of the negative number, right? So an inequality with negative numbers, as the negative number gets bigger, like negative 20, negative 30, it's actually getting smaller. So the value of it is decreasing. So that's kind of playing into this, flipping the sign, because now it's worth kind of the opposite of what it originally was worth, because it's